Humanity's time to act is running out. We are now creating so much water pollution that we are rapidly poisoning our planet and all life on it. For example, according to the IUCN, 8 million tons of plastic end up on the ocean each year, which make up 80% of all marine debris. This debris ends up in hard-to-reach areas with circular ocean currents called gyres from all kinds of water and land-based sources. This marine debris can be ingested by or lacerate sea animals. Furthermore, they can break down into non-biodegradable micro or nano-sized particles that release toxins and accumulate all the way up the food chain. If this problem is not quickly resolved, it could have disastrous consequences. For example, according to Ellen MacArthur, there could be more plastic than fish in the oceans as early as 2050 if we continue the current state of water pollution production. It is this dire problem that Team ODIN is determined to solve. We are a group of experienced problem solvers from Bragg University. We have an extensive background in machine learning and AUV engineering. Our skills have been tested on an international stage, and our previous AUV project, Bragg Duburi, stands as proof. Coming from Bangladesh, we are exceptionally passionate about water pollution. This is because our country has one of the world's largest river systems, but our water bodies are extensively polluted because we are a developing nation with poor waste management. This water pollution is harming our country's incredible natural wealth, and thus we are strongly motivated to help solve the issue for our own country and the rest of the world. And the solution we wish to present is Project ODIN, which stands for Observe, Detect, Imprison, and Neutralize. It is an underwater rover that will collect and remove marine debris from these ocean gyres before it can break down and become irrecoverable. It will be able to maneuver itself autonomously or be piloted using the Pixhawk UX-4. We will exploit machine learning using TensorFlow object detection and the YOLO5 algorithm to detect marine debris, which will be captured by a mechanism that we custom designed. We will be able to use data from NASA satellites to map out locations in the world's oceans with the highest concentration of marine debris buildup. In this way, we will be able to work out the areas where the rover's deployment will be most effective. We believe our rover will be able to access regions of the oceans that are difficult to reach and remove pollution from by conventional means. Also, being autonomous will make carrying out debris collection missions much easier and more frequent by greatly reducing the amount of trained manpower and field work needed. With greater funding and more advancement in battery technology and solar energy, it is possible to envision a future where we can have many such rovers patrolling the world's oceans. They can follow debris from the source to these ocean gyres where they end up and monitor, detect, and remove debris in a way that modern boats and satellites simply cannot. Thus, we truly believe that our rover can pave the way for a future with oceans that are clear of all man-made debris.